Okay. Good afternoon, everyone. Good morning, good evening, depending on where you are. It's 4 o'clock in the UK. So we're getting started. We are lucky to have an awesome session today. It will be Tiny Machine Learning with Arduino. We'll have Massimo Banzi, co-founder of Arduino, here with us today to talk about how Arduino is doing tiny machine learning. And this is obviously the UK area group for our third meetup. So I'm excited and looking forward to this talk. The TinyML sponsors are ARM, TinyML's strategic partner, DeepLight, Edge Impulse, Maxim Integrated, Kixo, and Reality AI, and SynSense. So we just had an awesome TinyML Summit 2021. We actually had quite a lot of participants, 5,006 registered attendees, and over 150 sessions recorded. And they will all be available on the TinyML YouTube channel. You could find it here on the right. And obviously you'll have the slides afterwards, so you can get all the links that we'll talk about today afterwards as well. You don't need to take any screenshots. And in June, there's an upcoming EMEA TinyML Summit that we're excited about. The deadline for the abstracts is May 1st, and we're still accepting sponsorships, and you can message the email that you see below if you're looking to sponsor the event. The next TinyML talk will be Tuesday, April 27th. It will be an awesome talk as part of the global TinyML talks. You can see here that if you're interested in talking at TinyML worldwide or UK, you can message talks@tinyml.org with your title and abstract and your details. Okay, and the local UK committee, I'm happy to be part of this awesome group of people that is running this UK meetup. We unfortunately we still haven't had an in-person event, but I'm looking forward to our first in-person event, hopefully soon. And the group is made of 4 people. So it's me, Dominic Binks, VP of Technology at Audio Analytic, Gianmarco Iodice, ML Tech Lead at ARM, and Neil Cooper, VP of Marketing at Audio Analytic. I'm excited to be able to host this awesome talk by Massimo Banzi, co-founder of Arduino. Welcome, Massimo.
Thank you very much. Good afternoon, everyone. So thank you, Alessandro. I'm really glad to be here. So today, I'm just gonna show a little bit of how you can run some tiny machine learning on Arduino devices. So this is not going to be like a super in-depth, mega technical session. It's going to be mostly about showing how you can do and how you can do it on Arduino devices, showing some example, giving some pointers for some examples. But also I wanted to take a chance also to talk to people about what Arduino is. But I know everyone knows what Arduino is. I'm not going to say something obvious, but it's very interesting to me that right now people sometimes they still have an image of Arduino, which is kind of based on kind of the stuff that we've been doing for a long time. Now it's almost like Ford would be known because of their Model T, and nobody knew what kind of cars they do now. And that's one of the strange things that's happening with Arduino. A lot of people are still kind of fixated with the old 8-bit stuff, but so maybe we can shed some light on some of the stuff that we've been doing. So let's have a quick look about, in Arduino, we have this kind of motto, this vision, I guess, that we want to enable anyone to innovate by making complex technology simple to use. And I really like this because it's very simple, to the point, and it kind of indicates this idea that the world we live in is full of these interesting technologies that are perceived to be complex. But if you actually explain them with the right language, with the right tools, you get a lot of people to understand this technology, and they can use them creatively to innovate, sometimes to even to change the world in a positive way. So this idea of simplifying technology for people, it's very, very, to us, it's very important. Just some numbers just to show that Arduino is one of the, I think it's like website number 3,000 in the world in terms of popularity, because 29 million people going to the, that's like a medium-sized country, you know, of people coming to see Arduino. And the forum now has surpassed 1 million users now since I wrote this slide. And we recently migrated to a new platform on Discord. And apparently we're probably the biggest Discord community, discourse community out there. So the IDE is downloaded millions of times. So there's a lot of interesting stuff. The community is very big, it's very popular. But, and one of the things that we really like is this effect that we noticed that, yes, Arduino is designed to be easy for beginners, but a lot of professionals really like the fact that with Arduino, they can very quickly get some stuff done. And I think that's, in my opinion, a very interesting duality of what we try to do. We try to build tools that are simple for beginners, but that make, in a way, innovation very quick for professionals. So let's have a look at the latest hardware from Arduino. So one of the boards that you would see quite a bit in tiny machine learning right now is this board called the Arduino Nano BLE Sense, which is an evolution of the classic Arduino Nano that a lot of people know. It's a very small, it's actually it's very small, is this board down here in terms of size. And it's interesting because it's got a Cortex M4F with very good quality Bluetooth. The processor is from Nordic. 1 megabyte of flash, 256K of RAM. But on top of that, and one of the reasons why it's also quite popular for tiny machine learning is that it comes out of the box with microphone, and IMU, a gesture sensor, a light sensor, a proximity sensor, pressure, temperature, and humidity. So if you want to build something, or you even just want to learn or prototype, everything that you need, well, quite a lot of sensors are already included in the board. So you can build a lot of very cool projects with basically building no hardware, apart from just plugging the board to your computer. And that's been it's been very, very popular, as I said, to a lot of people that are learning machine learning. They want to use something physical. And in fact, out of that particular work that we have done, also, we built this little kit that connects a BLE Sense with a simple VGA camera. And this was built essentially to make it simple for us to do simple computer vision. And then suddenly it ended up becoming a tool that's used also by Harvard and edX to teach about tiny machine learning. So it became a kit. It's called the Tiny Machine Learning Kit. It contains that PCB that you see here, camera, board, the carrier board, USB cable. And if you go to this website, this is the e-learning platform by Harvard, you can actually sign up for free to a whole class, and you can actually get a certificate. You can actually get a professional certificate for this, where you actually learn about tiny machine learning, and then you actually learn how to implement it. And this is, and they use this particular board. And here's the website with all the teaching materials. So, because this was done first as a class internally at Harvard, and then it became an edX platform. So I think that's something that I find quite interesting, that you can now get this type of classes at universities, but also they now have these online e-learning classes. And I think that's very important to make tiny machine learning very, very, very wide. Just to take a second, one of the reasons why I became interested in tiny machine learning is that we've been processing sensor data forever at Arduino. And years ago, we did a board that contained a processor, that contained a little hardware implementation of a neural network. They call it a neural network, mostly was a classifier for pattern, but they call it a neural network. And it was very fascinating to me that you could run this algorithm on a very small hardware. So that's why we started to investigate. And then we ended up first partnering with Google, and then now with Harvard. And we are continuing partnering with other people, and you'll see later. But to me, it's super fascinating that you can run this algorithm that years ago were designed to run on large computing platforms, and now you can run them on something this small that is essentially the size of a postage stamp. So the other big family that's important in what we are doing is this Portenta family. The Portenta H7 is the first member of this family. You will see more of them coming. The idea is that it's a fairly small format. It's vaguely 1 inch by 3 inch in size, or 25 by 75 vaguely millimeters. And it's quite interesting because it runs an STM32 dual core microcontroller. So you have an ARM Cortex-M7 at 480 megahertz and an ARM Cortex-M4 at 240 megahertz running in parallel inside the processor. This board is a beast. It also has an ARM processor that runs the Wi-Fi Bluetooth module. It's got 64 megabytes of RAM. It's got 128 megabytes of flash. It supports 2 different types of crypto elements. As I mentioned, it's got Wi-Fi Bluetooth. The processor supports Ethernet, CAN, USB-C. If you plug a USB-C hub onto this port, you can actually get video output as well from this particular model. So we realized you could build some sophisticated devices with included some sort of a GUI attached to it, and this is operating on the ARM Mbed OS operating system. So there is the Arduino framework is implemented on top of Mbed OS. And this has enabled us to do all sorts of things that would be impossible with just the classic bare metal framework. So for example, you can do RPC between the cores. So there are interesting scenarios where you could run your more time-critical code on the Cortex-M4 and then turn on and off the Cortex-M7 to run machine learning tasks or run high-level languages like Python, for example. So an Mbed OS allows us to actually handle all the different in a way, the communication between the cores, running multitasking. So it is Arduino, yes, but it's a very, very, very different from what you are used to. And we released this thing called the Portenta Vision Shield, which is one of the things that I haven't mentioned, but will be clearer later, is that on the back of this board, there are 2 high-density connectors that break out 160 pins of all the different pins that the different processors on this board make available. And so this means that you can take a module like this and you can just snap it and create a little sandwich. And this thing, for example, has an IMAX camera. So these are low power black and white cameras. Dual microphone, so you can do also beamforming and different things. It supports LoRa, Ethernet, and an SD card, and depending on the model that you buy, you get the one with Ethernet or the one with LoRa on it. It's interesting because if you start to take the LoRa one and then you snap it on the back of a Portenta, and then you are careful in the way you manage the power management in your code, you can really build a battery-powered computer vision application, or maybe even audio recognition application that then uses LoRa just to send data to a cloud. And I think that's a very interesting scenario to me, to use TinyML for battery-powered computer vision and then using LoRa for data, because it brings a lot of value. And also for me, I really like the fact that this encourages, in a way, privacy, because you're not sending images to a cloud. You're only sending very, very specific data. And I think that's one of the very nice things of running machine learning on these kind of devices. I'm just going to give you a quick example of something that a customer made, which is they took this vision shield with the Portenta, they mounted it on this little robotic arm. This company builds machines that assemble parts for cars. So they build automation for car manufacturer. This particular example is using the computer vision to make sure that operators have mounted the right clips onto a car part. And I think the interesting scenario for them was that they could train the device, run the machine learning in this device, and they didn't have to send the data to another machine that would do the video, the computer vision. So they are doing this directly inside the Portenta. And I thought that was a very interesting scenario. Another piece of hardware that I think it's interesting to bring everything together is this thing that we call the Portenta Breakout carrier. So this breaks out most of the pins, I guess all of the pins that are on a Portenta, and it actually still allows you to snap something at the back. So you can put a Portenta on one side and a vision shield on the other, but then you have everything broken out. Gigabit Ethernet, USB host, and every single pin broken out. And you can even connect camera modules on this side. And we adopted the Openmv standard. So you can actually get from Openmv a whole selection of cameras, including infrared cameras. And I think that's quite, again, something that I really, really like. Two very quick other things about tools. If you haven't, you should check out the Arduino Ide 2.0. It's in beta. We released it a few months ago. And basically, I think that the very interesting about this is that it's built with the same kind of framework that's behind Microsoft Visual Studio, but it's not Visual Studio. So it's, in a way, it's built although following the Arduino standard for privacy, but it's now fully open source. It supports all the things that are supported by a modern IDE. So you have autocomplete, the equivalent of what Microsoft calls IntelliSense. So there is a language server that does a lot of interesting things. So when you are in a certain point in the code, it's not just a random autocomplete. And then it supports debugging. So if you have a JTAG dongle connected, you can do this. Or you can also use Lauterbach is making available a free version of that software, so that you can even debug Arduino code without a specific dongle. And this is also another interesting option. The other thing is that we did a partnership with Openmv. So now the Openmv IDE is supported on the Portenta. So you can build computer vision, and we will see in a few minutes machine learning, more specific machine learning applications using Openmv. And it's very interesting because the example you saw before of the robot arm going around and taking some, making sure that the parts were assembled for visual inspection was built by that company using Openmv. And it's very interesting because that particular company has adopted Arduino a few years ago to do industrial automation, exactly because they can do a lot of work, although they don't have people with like deep knowledge of machine learning. They can still take advantage of machine learning to help them in their work, but they don't have to have a large R&D department. I think that's a very interesting scenario. So I'm going to show you a couple of examples of tiny machine learning with Arduino. One of them is very classic, gesture recognition. We're going to use the Arduino Nano BLE Sense. So I'm just going to show you the process that we used for this particular example. This is a tutorial that there will be a link. You can find it on GitHub. So as I mentioned, this board comes with a IMU, so it's able to detect all sorts of different information about movement, acceleration, there's a gyroscope, there's a magnetometer, so you can really gather a lot of information about how this device is moving in space. And here, this is the link to the GitHub where you can find the tutorial. But effectively, you start off with one sketch from Arduino called IMU capture. You install it into your Arduino board. You compile it, you run it. And what you get is this. You get essentially a CSV data coming from the serial port that basically tells you about acceleration and the gyroscope data. And the interesting thing is that in the Arduino Ide, there's a button called Serial Plotter, and you can actually get the data in the form of a graph. So basically, the idea here is that you can visualize in real time the data coming from the different gestures. The objective of this project is to actually create a virtual keyboard that turns a gesture into an emoji, as just an example. But the idea is, once you have opened the serial monitor and you see the CSV data, the idea is that you move and you do the same gesture 10 times, and then you capture the data from the serial monitor and you save it into a file. For example, the files are called punch and flex in this particular case. So you get two different files for punching and flexing. And once you've done that, there is a link to this. It's a Jupyter notebook that is hosted on Google Colab. And it's an interesting thing because you can go through the code that does all the training, but also there's an interesting snippet of code that takes the model that's generated by TensorFlow and gets converted into a .h file for Arduino. So basically, if you follow this, this link, let's say if you expand, there's a section of the notebook where it says drag the two files here. The two files gets uploaded into the notebook, and then you get a model.h. At this point, you go to the IDE. There is another example called IMU classifier. You just paste the .h that you have received from Google, and then your serial monitor will give you this. Every time you do a gesture, if it's a flex or a punch, you will get obviously the level of confidence for this particular thing. So what we did here, we added essentially an example called Emoji Button.ino that adds essentially the ability to emulate a keyboard. So once you put everything together, what you get is this. When somebody punches or flexes, they get a different emoji. This was built as a sort of as an example by Sandeep Mistry and Don Coleman for a workshop they did. And one of the interesting thing about this is that I've had somebody tell me, hey, but this is actually interesting, apart from the fact that it's a fun example, since this thing is emulating a keyboard, this means that maybe somebody that has some kind of disability could actually associate a gesture with a certain sequence of keystrokes. So they could be able to operate some type of equipment based on gesture. And this is all running inside the Nano BLE Sense with no external equipment. I'm going to show you another example. In this case, we're going to use Openmv. So the previous example was all Arduino plus a ton of C++. And this particular version is it's based on Openmv. So the idea is that you need a Portenta with a Vision Shield, a USB-C cable, and you need an edge impulse account for training the model. And then you need fruit or other objects. So the person who built this example, Sebastian Romero, used fruits for this. But you can actually use whatever image. So in a way, if you, again, going back to the robot application you saw at the beginning, they used the similar, instead of taking pictures of bananas and apples, they used pictures of car parts with or without the mounted parts. So the general idea is to gather a bunch of examples of images, then collect them, go through this process of actually training the model, and then build a classifier that tells you with a certain level of confidence what kind of object you're looking at. So the interesting thing is that the Openmv, as I said, supports Portenta directly. There's actually an interesting dataset editor. So you do new dataset, and then you start taking pictures of object using this sketch, and these get accumulated in different folders. Each one of these folders represents classes. So you can basically orient the different images in different classes. Once you've done that, as long as you have an Edge Impulse account, you can basically click on this button, and then the Openmv IDE will open a connection to the Edge Impulse website, and it will basically upload all these images divided in the different classes. And then here you will find all the training data with the label next to it. It says there are 4 labels, and you can see some example, the raw image. Here in this particular example, they collected 1,000 images. So once you are here, you can then go to the next step where you actually create the impulse. So you start here, you say, hey, I have, the images are 48 by 48 pixels. And then you basically, you say, I'm going to use transfer learning. And then I need an output feature, which is made of 4 different classes. So when you save the impulse, then here you can look at the different parameters, look at the raw data. And then you have a button that says generate features. And you end up in another section where you can basically start the actual training of the algorithm. So here you see the different images in a way clustered in a 3D space. So you can explore the features. And then once you generated the features, you end up in this situation where you basically have built in a way your model. Here's some indication of the model they're using, MobileNet v2, input layer, so based on a bunch of 2,000 features. So there's a number of parameters. So you hit the start training, and at this point, this will crunch all the numbers and get you a trained model. Once you're done, the interesting thing about Edge Impulse is that you can either click on Arduino library, and this will generate an Arduino library for you that runs on an Arduino and classifies the images and basically tells you the level of confidence of about each image is being fed into it, or it generates a library that ends up in Openmv. So you can click on Openmv, hit build. And then in Openmv, the core of the classifier is this. It's a very simple, very simple code. The core is very simple. At the end, it says, if confidence more than 0.9 and label different from unknown, it says it's a, so it just tells you it's a banana. Here you can see an example of when you use Openmv, the image capture from the camera, it's visualized in this frame buffer preview, and then you get a histogram. Here you get the code. This is the full code of the classifier. And here you get the different predictions saying, it's an apple, it's a banana. So in this case, it correctly identified that this is an apple. And so you can find the full tutorial here. So you can, if you want, you can go through the whole thing and build it yourself. And there's a bunch of tutorials available. There's literally a lot of them. So I'm not going to go through a lot of them because we have limited amount of time. But for example, you can go to this address and you can see the person detection example that this was put together by the group where Alessandro works. So if you go to this link, you will find the example for the Portenta that does person detection on a Portenta. Or for example, if you go to this tutorial on Edge Impulse, you can use your Nano BLE Sense to collect, to understand keywords. Again, that's another big interesting topic. So be able to detect the keyword locally and then enable the rest of the voice recognition to happen maybe on a cloud. But first you sort of block in a way, you turn on the microphone only after you did the keyword detection. So here you have a whole tutorial on how to do it on Edge Impulse. Another interesting thing you should check out is this AutoML platform by Quixo. They support the Nano BLE as we have seen before, but their classifiers are quite optimized so that you can actually run some of this code on the Cortex M0 based board. So there's a number of boards from Arduino in the MKR family that have all sorts of different connectivity like LoRa, Wi-Fi, Bluetooth, GSM, narrowband IoT, LTE. So the fact that you can run the model on a Cortex M0 means that you can, for example, process some sensor data using their tool, and then use this kind of quite vast number of connectivity options to just send the data to the cloud. So I think it's quite cool that it runs. So check it out on their website. And that's about it for me right now. If I've seen that there were a few questions. If you guys have questions, I'm ready to answer.
Cool. Thank you so much, Massimo. We've got a few questions coming in. Before getting those questions, I just wanted to launch a quick poll. So I'll give everyone a chance to take this poll for about 5 minutes, and then we'll start. So I'm going to launch the poll now, and then we can take the questions. Okay, so I'll read out a couple of the questions here. So the first one was from Carlos. He's asking whether there's any plans to have thermal or night vision cameras on the Vision Shield.
So there are some requests from customers about that kind of cameras. At the moment, the quickest way to do that is to use this breakout board and plug an Openmv, just the camera module on it. But there are some discussion right now with customers that are requesting specific cameras, so they might appear at some point.
Cool. Thank you for that. I'm
But
going to
also,
remind everyone.
I'm just going to
Sorry, go
add
on.
very quickly. I also, anybody who's seen something that Arduino does that they think can be, you know, they might need like a special variation of something, I encourage all of us all of you to contact us, because we do all the time custom versions of things for specific customers. So just talk to us. The fact that you let us know that you need something helps me convince internally people that we need the thermal camera. But if I don't get people writing to us saying, I want the thermal camera, then you know, it's harder for me to say we need the thermal camera. Thank you.
Cool. And Massimo, would you say the best way to contact you is through this email or a forum or?
Yeah, I mean, the best way is go through this, either send me an email, or there is a website called Arduino Pro that you can find on the main Arduino website. On the Arduino Pro website, they have a contact. There's like contact us. And in a way, if you do it there, it goes directly to the people who are building the more professional tools in Arduino. So you get a much more fast and direct response. Because if you go into the forum is, it's like shouting in the middle of a, you know, U2 concert. You know, it's kind of hard for other people to hear you.
Cool. Okay. Thank you. So we've answered that live. And the second question is from Sylvain. He's saying, is there any plan to include other frameworks other than TensorFlow Lite in Arduino? He's mentioning PyTorch as an example.
So we are always looking at different options. So for example, we also experimented a little bit with building simplified version of some algorithms, because we realized, and you can see it in our blog for things we posted like at the beginning of 2020, that we realized that some of the things that we were doing with TensorFlow could be done just by a regular nearest neighbor classifier. So we're also, in a way, it's quite interesting in a way to look at what could be implemented. At the moment, we are working with a partner, which is a big research institution in Europe. They developed very interesting, super simple, well, very sophisticated, but quite lightweight in terms of resources, AI library. And we are going to be, towards the end of April, there will be an announcement about that. I unfortunately can't say very much now, but but yeah, that one will be an example of something that's designed from the ground up in C language for a microcontroller environment. So it will squeeze out the if there are other frameworks that people want, as I said, send us a message.
Cool. So I'm going through there's quite a few questions. I'm just going to remind everyone, if you want to ask questions, ask them in the Q&A box and we'll take them live. So I've got another one here, the one that's got more votes. Do you plan or want to collaborate with Microsoft to develop IDE and or connect with their cloud AI technologies?
Sorry, can you say the question again? I didn't understand.
Do you plan, or do you have plans, or do you want to collaborate with Microsoft to develop, I guess, an integrated IDE with them and or connect with their cloud AI technologies?
So, well, we have done a bunch of things with Microsoft in the past, so we collaborate with them whenever there is a chance, whenever we have a common thing to do. For example, their Visual Studio Code supports Arduino. The extension for Arduino was developed by Microsoft. We are trying to figure out how to update that particular extension to use more modern Arduino technology like the Arduino CLI, the command line interface. In terms of interfacing with the cloud, there's two different things. So there is a library for Arduino that connects to Azure. In terms of using their cloud-based ML with Arduino, it's based on how many people. It's either how many people request it, or if Microsoft approach us and says, "Hey, why don't we do it?" Then we do it. But it's about if there is a reason for collaborating, we do partnership, we build things with a lot of people.
Cool. The next one from Joseph, he's asking, what is currently the biggest use case for TinyML on Arduino? And I guess he's giving some examples here: education, small, medium companies doing R&D, or putting stuff into their products.
Well, I think that's an interesting question, because there's one part of Arduino that's always been about education. So there is work going on to try to build ways to teach about machine learning that's understandable to a wider audience. That's one of the issues, that sometimes some of these machine learning topics are described in terms of complex math when they are algorithms. So they could be basically described as essentially a programming problem. And in a way, described like a programming problem, they become much more understandable by a lot of people. So there is a lot of work, and this tiny machine learning kit is going into that direction. But we are even looking at ways that how do you teach machine learning to kids? And then the other use cases are, we work with a bunch of, for example, system integrator who build solutions like the people that I mentioned, but there's a bunch of other people. So I would say different kind of computer vision problems, where the fact that there is a self-contained device that has basically no need for in certain type of industrial automation, we noticed there's a number of people that are allergic to Linux. So the fact that you have to run an operating system with different layers like that just to do some simple tasks. So in a way, it's interesting, because these super powerful microcontrollers, they can basically do things that maybe a Linux machine would do, but they only run that particular application to the maximum of their capability. So some of the scenarios are about that: single function, self-contained devices. So at the moment is a lot of either people who are prototyping or people who are doing system integrators. So they are building specific solution to specific problems. And some verticals are starting to emerge. I'm not gonna reveal the secrets right now, but there are some interesting verticals that are coming out, looking at the work that some of these, I would say one of the big problems that we see the industry, maybe problems or maybe opportunities we see the industry facing right now, is the idea of retrofitting. If you're trying to take, for example, in a way, an industrial application, and you have, for example, a factory with different type of machinery, and not all the machineries will be equipped with ways to interact with them digitally. Also, if you look at the factory, sometimes you see that the more you move along the factory, the age of the machines goes up, because they are all built by people across multiple years. And so the ability to build an ad hoc solution to interface whatever machine, it seems to be one of the things that people try to do a lot with Arduino.
Well, thank you for the very detailed answer. We've got a couple more. So one is any comment on Ethernet for Arduino Portenta? Actually, examples, sorry, for Ethernet for Arduino Portenta. Jeremy is saying that he seems to think that the general Arduino Ethernet examples don't run on the Portenta. He also reported an issue. Any thoughts, anything to share on that?
So there is a whole team, but probably the single largest team in Arduino writes content and builds examples. It is probably the single largest team in the whole Arduino. And, it's on their radar. They are working on it. I know that Jeremy submitted an issue about that, among others. And so we are getting to that. It's always crazy. There's always so much stuff going on. So we are getting there.
Okay. The next question is around, will the demos run on non-Arduino hardware? So this OR Mitchell is asking whether there's going to be availability of running the same examples on non-Arduino hardware.
In a way, a lot of these frameworks that you see about TinyML, they tend to come with Arduino supports out of the box, also because, it's just a lot easier to make stuff happen using Arduino, so it's an obvious choice. Some of the TensorFlow examples over time, Google has ported to other processors. But obviously, the work that we do is about making it simple to do these things on an Arduino. So
makes sense.
It's up to you to adapt the examples.
Okay, Vahe is asking, is it possible to use USB-C port to connect with external GPUs? Interesting question.
Wow. Okay, that's interesting. Off the top of my head, I am not sure that can be done. I mean, it could be done, but there might be an insane amount of code that needs to be written in order to do that. So imagine, the processor inside the Portenta has some kind of an accelerator, which is based mostly on 2D acceleration, because it was designed to build essentially GUIs for devices, for a coffee machine or a CNC controller. So I don't think that running a GPU is probably not the scenario that's supported.
Interesting thought, though, connecting an external GPU.
No, it's Arduino. I mean, there is the possibility to connect accelerators. There are several accelerators for ML tasks that might be interfaceable with the Portenta. And we sent the Portenta to the Coral team at Google, but they haven't ported the code yet.
Cool. So I'll take this one from Parikshit. What is maximum FPS achievable for Openmv and Portenta Vision Shield? And then also, which one will be better for real-time object detection applications?
Well, so Openmv is quite optimized, but as you've seen with the Portenta, that particular code was just an example code, so it wasn't super optimized. It was getting about 7 frames per second or something like that. But it is quite, it's a lot. It consumes a lot less power than like a full-on camera. If you were to implement the same code in C++, in pure C++ with the proper optimization, the frame rate will go up quite, I would say would go quite significantly. Consider that on this Nano BLE Sense with this VGA camera, we get 5 frames per second. So in pure C++ on the Cortex M4F. So it depends how optimized is the code. Openmv is quite optimized, but it has an insanely, how do you say, the productivity is through the roof. You build complicated stuff very, very quickly.
I can also say that that's true. I mean, it's super quick to use. Yeah, the IDE is great. Can TinyML be used to program the processor within a Google Coral or Jetson TX to both use a Cortex processor? I guess this is beyond the Arduino conversation. So I guess it goes back to what you said before, Massimo. I don't know if you want to share any more comments. I guess it's beyond the Arduino stuff, and
there are several types of Coral accelerator. There was one particular accelerator I remember when we had this discussion, which this was pre-COVID, then COVID happened, and COVID messed up a lot of things. But there was one that had a SPI interface, so it was interfaceable to things like an Arduino. And so there were some idea that this could happen, but at the moment we don't have.
Cool. Another a Portenta-related question, actually. What is the power consumption of a Portenta running an image recognition model? Any idea?
So I am super sorry, I haven't done that measurement, and I don't want to give you a random number. So I'm just going to say, sorry, I haven't measured that, but that's an interesting thing that we should totally do.
Cool. And then I guess another last couple quick questions. So one is, are you planning to support dlib C++ libraries? I guess this is probably unrelated to TinyML specifically, but yeah, dlib C++ libraries. I haven't heard of them, so I'm not sure if.
I'm trying to understand who they are. Oh, okay. Well, in general, any C++ code or C code runs on an Arduino. If it compiles on a microcontroller, it runs on an Arduino. Again, I am talking about the Arduino based on an ARM processor. The 8-bit Arduinos, let's leave them where they are. But the 32-bit ARM processor based, you can compile almost anything. If it runs on a micro, it runs on an Arduino. In fact, if you look at it, the TensorFlow Lite Micro, the Arduino library is essentially the C++ library wrapped with some Arduino code just to make it more interfaceable with Arduino. So I can see that this dlib, it's a big collection of algorithms with support vector machines or kernels of different kind. It says here it should work on any POSIX system. The problem is to see if it fits. Maybe in a Portenta it will fit. But, this is talking about the Solaris HP UX, so slightly larger machines.
Cool. Another question, maybe that's worthwhile taking just before we close. Someone is a STEM educator, Joel, and he's saying, any idea of how you can make it easier for novices like kids to learn TinyML? Since this is the unique DNA of Arduino, do you have any thoughts?
Yeah, I have been spending quite a lot of time thinking about that. Actually, one of the other things, the other thing I do apart from working with Arduino is I teach interaction designs mostly to adults, but I use that also to understand how that applies to younger people. I ran a number of classes about machine learning because although my students are adults, they don't have a background in technology. So The same way when we made Arduino, we had to figure out ways to teach essentially electronics to somebody that knows nothing about programming or electronics. So we did a number of experiments. One thing that came back, as I said before, unfortunately, a lot of the tutorials and a lot of the texts about ML, they represent it as a mathematical problem, because I guess that's how it fits in the context of computer science research in an academic context. But in a way, they're algorithms, so they can be represented with code, and you can make code you can make code understandable to people. So just to give you an example, an experiment that I did, a little bit of the work I did with this other person called Dominic Pajak, who works for ARM, and is to start to go back and look at the algorithms that before they were like deep neural networks. So for example, you can build a single perceptron in Arduino. You connect a color sensor to an Arduino, and then you can start teaching about the single perceptron to classify colors. And then out of that, you start to build up the complexity. So in Arduino, we tried always to start with very simple and build up the complexity. So what happens is that you can then start to look at, for example, nearest neighbor classifiers, and then you can start to look at, for example, simple neural networks, and then you can build up deep, and then you have to find an example that engages with kids, essentially at every level of this. I did an experiment a while ago. We built this kind of a Lego block sorter using essentially a color sensor and a servo motor and a button that says yes, no. And basically with this tool, kids understood the concept of training something and classifying by color. No? So if you build the examples like this, people will, even people or kids will understand the principles, and then you build up. You know, I obviously have a constructivist approach, so obviously I look at that like that. It's a very long topic. There should probably there will be a separate TinyML, streaming just for that. But
very interesting. Okay, so again, thank you to all our sponsors. ARM, TinyML strategic partner, DeepLight, Edge Impulse, Maxim Integrated, Kixo, Reality AI, and SynSense. You can find more information on all the different sponsors on the slides attached to this presentation. So ARM, DeepLight, Edge Impulse, Maxim Integrated, and Kixo, and Reality AI, and SynSense. And the next TinyML talk will be Tuesday, April 27th. And if you're interested in giving a talk or presenting at TinyML, send us an email on talks@tinyml.org. And with that, I just wanted to say a big thank you on behalf of the local UK TinyML Meetup to Massimo Banzi for participating today. Thank you so much, Massimo. Real pleasure as always. Thank you.